Welcome to college algebra. Today we would be discussing section 8.4, which talks about systems of nonlinear equations in two variables. So to begin, we would um, define we will write down the standard form of a system of two nonlinear equations in two variables as. So a system of two nonlinear equations in two variables. In two variables also called a nonlinear system. Contains at least one frequency communication that cannot be expressed in the form AX plus BY equality. So we express a linear system of equations this way. So if we have a set of equations where one of them cannot be, where at least one of them cannot be expressed in a linear form, then we say that we have a nonlinear system. Um, as with um, as with linear systems in two variables, the solution of nonlinear system, if there is one, corresponds to the intersection of the graphs of the equations in the system. So just like we found out in the solution to systems of linear equations, the solutions to nonlinear system of equations is at the point where the graphs uh, of of two of the equations intersect. The point of intersection of two of the equations becomes the solution to the system. Let's look at our first example. So this is example one, and it says we have a system x squared is equal to y minus 1, and our second equation is x minus y is equal to -1. So we have two equations, equation 1 and equation 2. Um, so to solve this system, let's label this as equation 1. And let's label this as equation 2. So um, to solve this system from equation 1, um, from equation 1, we know that if we add 1 on both sides, we'll have y is equal to x squared plus 1. So if we can write y in terms of x, then we can substitute this into equation 2. So our next step will be substitute y is equal to x squared plus 1 into equation 2. So that would become 4x minus y, which now is equal to x squared plus 1 is equal to -1. All right, so from here we have 4x, if you multiply through by the negative, 4x minus x squared minus 1 is equal to -1. And if we group, we add 1 on both sides, then we have 4x minus x squared minus 1 plus 1 is equal to 0. So that means we have 4x minus x squared is equal to 0. So we now have a quadratic equation that we can factorize to solve for x. So for this, if we factor out x, we have x times 4 minus x is equal to 0. So this means x is equal to 0, or 4 minus x is equal to 0, which implies x is equal to 4. All right, so we have two values for x. X is equal to 0 and x is equal to 4. So if x is equal to 0, x is equal to 0, let's find the value of y. Y, which is equal to x squared plus 1, to become 0 squared plus 1, which gives us 1. And if x is equal to 4, then we have y, which is equal to x squared plus 1, becomes 4 squared plus 1, which gives us 17. So the proposed solutions are, the proposed solutions are proposed solutions are when x is equal to 0, y is equal to 1, and when x is equal to 4, y is equal to 17. Okay, these are the other pairs that satisfy the equation. So we can write the solution set as solution set on the written as curly bracket, other pair 0, 1, and 4, 17. So this can be the solution sets for the solution to this example. Let's look at solving linear systems by the addition method. So we found out, all right, so what I should have mentioned in this example 1, what we did was to solve the linear system by the substitution method. So how we solve this was by the substitution method. And so similarly, like we did for the linear systems, where we use substitution, and we use another method we looked at was also the method. So let's also look at solving a nonlinear system by the addition method. solving a nonlinear system by the addition of factors. Let's use an example. We should be also an example. We can see. Let me see, solve the system. Solve the system 3x squared plus 3y plus 3y squared is equal to 35. And 4x squared plus 3y squared is equal to 48. All right. So the first thing is let's rewrite these equations in standard form. That means we write we put everything on the left, and the only thing that will be left on the right will be zero. So we write in standard form. So that would be 4 3x squared plus 3y squared. So let's write it in standard form. So that would be 3x squared plus 2y squared minus 35 is equal to 0. And this will be our first equation. And the second equation is 4x squared plus 3y squared minus 48 is equal to 0. And this will be our second equation. All right, so now we can multiply. We are using the addition method, so we want to eliminate one of either the x or the y term. So let's go with eliminating the x. Let's go with eliminating let's go by eliminating the y terms. We can eliminate each of the two that we pick. We can either decide we want to eliminate the x term first or the y squared term first. So this one, let's eliminate the y term first. And to do that, we will have to multiply the coefficients of the y squared in both equations by numbers such that they become the same in both first equation and the second equation. So what I mean is if we multiply equation 1 by 3, then we multiply equation 2 by equation 2 by 2, then the coefficients of the y squared will be the same. So this is what I mean. So if you multiply equation 1 by 3, you're going to have 3 times 3x squared, 9 squared, plus 3 times 2, 6y squared, minus 3 times 35, which is 105, is equal to 0. And if you multiply equation 2 by 2, then we have 8x squared, 4 times 2 is 8x squared, plus 3 times 2 is 6y squared, minus 48 times 2, which is 96, is equal to 0. Okay, so at this point, if we subtract, let me call this equation 3 and equation 4. If we subtract equation 4 from 3, if we subtract equation 4 from 3, that will be 9x squared minus 8x squared will give us x squared, and 6y squared minus 6y squared is equal to 0, and minus 105 minus negative 96. So negative 105 minus negative 106 becomes negative 105 plus positive 96. and that becomes -9 is equal to 0. All right, so from here, we have x squared minus 9 is equal to 0. So x squared is equal to 9, which means x is equal to plus or minus square root of 9, which is equal to plus or minus 3. So x is equal to -3 or +3. All right, so now that we have the x values, let us try to find the y values. Okay, so when x is equal to, if x is equal to +3, then if we, and we pick the first equation, which is 3x squared plus 2y is equal to 35. If x is equal to 3, then we have 3 times 3 squared plus 2y is equal to 35. 3 times 3 squared, this is 3 times 3 squared is 9 plus times 9 plus 2y is equal to 35. So 3 times 9 is also 27. So 27 plus 2y is equal to 35. And if you multiply both sides by 27, then we have 2y squared is equal to 8. And let's divide both sides by 2. Then we have y squared is equal to 4, which means y is equal to plus or minus square root of 4, which is plus or minus 2. So y is equal to plus or minus 2. So that means when x is equal to 3, we have the pairs. We have the other pairs. When x is equal to 3, we have 3 and y is 2, and also 3 again, and y is -2. So this is the solution we get for x is equal to 3. So now let's look at the solution when x is equal to -3. So if x is equal to -3, if x is equal to -3, our first equation again is 3x squared plus 2y squared is equal to 35. So if x is equal to -3, then we have 3 times -3 squared plus 2y squared is equal to 35. And so this becomes times -3 squared is 9 plus 2y squared. 2y squared is equal to 35. Okay, so this also becomes 27 plus 2y squared is equal to 35. So we subtract 27 on both sides, and it becomes 2y squared is equal to 35 minus 27, which equals to 8. So y squared is equal to 8. And so